NENOMATICA, where mathematics meets YouTube excellence. Step 1. Identify the general form. We start from the inequality f of log base a of x greater than or equal to 0. Here, f is any function of one variable. Step 2. Make the substitution t equals log base o of x. This transforms the inequality into f of t greater than or equal to 0. We now solve this purely algebraic or pre-calculus inequality in the variable t. Step 3. Translate your solution for t back to x. If the solution set for t is an interval or a union of intervals, then log base of x must lie in that set. Finally, convert each statement about log base of x to a statement about x using exponentials and the domain x greater than 0. For intuition, here is the graph of y equals log base 2 of x. It is monotone increasing, which means inequalities in t correspond directly to inequalities in x without flipping signs after exponentiating. In this lesson, we solve a logarithmic inequality step by step, exactly following the provided algorithm. Our problem is log base 4 of open parenthesis 3 to the x minus 1 close parenthesis times log base 1/4 of the fraction 3 to the x minus 1 over 16 is less than or equal to 3/4. Step 1. Let y equal 3 to the x minus 1. Then the inequality becomes log base 4 of y times log base 1/4 of y over 16 is less than or equal to 3/4. Also keep in mind the domain. Y must be strictly positive. Step 2. Use the change of base identity. Log base 1 over a of b equals negative log base a of b. Applying it with the equals 4 gives negative log base 4 of y over 16. Step 3. Expand the logarithm of a quotient. The rule is log base b of m over n equals log base b of m minus log base b of n. Applying that, we have minus, open bracket, log base 4 of y minus log base 4 of 16, close bracket. Step 4. Evaluate the constant. Since 16 equals 4 squared, log base 4 of 16 equals 2. Therefore, we get log base 4 of y times quantity 2 minus log base 4 of y is less than or equal to 3/4. Expanding the product gives 2 times log base 4 of y minus the square of log base 4 of y, less than or equal to 3/4. Step 5. Move all terms to the left and multiply by -1 to obtain a standard upward opening quadratic. We get open parenthesis log base 4 of y close parenthesis squared minus 2 times log base 4 of y plus 3/4 is greater than or equal to 0. Now set t equal to log base 4 of y. Step 6. Solve the quadratic inequality in t. The roots of t squared minus 2t plus 3/4 equals 0 are 1/2 and 3/2. Because the parabola opens upward, the expression is non-negative at and outside the roots. So t is less than or equal to 1/2, or t is greater than or equal to 3/2. Step 7. Back substitute. If t is less than or equal to 1/2, then log base 4 of y is less than or equal to 1/2. So 0 is less than y, and y is less than or equal to square root of 4, which is 2. With y equal 3 to the x minus 1, this becomes 0 less than 3 to the x minus 1, less than or equal to 2. So 1 is less than 3 to the x less than or equal to 3, which means 0 is less than x less than or equal to 1. Step 8. If t is greater than or equal to 3/2, then log base 4 of y is at least 3/2. So y is at least 4 to the 3/2, which equals 8. Therefore, 3 to the x minus 1 is greater than or equal to 8. So 3 to the x is greater than or equal to 9, which gives x greater than or equal to 2. Step 9. Combine both cases. On a number line, we shade from just above 0 up to 1 inclusive, and from 2 to infinity inclusive at 2. Therefore, the solution set is the union of the intervals open 0, 1 closed, and closed 2, infinity. Great work! We solved the inequality by substitution, change of base, converting to a quadratic, solving with a parabola viewpoint, and finally back substituting to x. Here is the problem we will solve. Read it aloud. Log base x of 2x is less than or equal to the square root of log base x of 2x cubed. Step 1. Expand using the product rule and the power rule for logarithms. The product rule says the log of m times n equals log m plus log n. The power rule says the log of m to the p equals p times log m. Step 2. Use the identity log base x of x equals 1. Then set y equal to log base x of 2. This converts the problem into a single variable radical inequality. Step 3. Case 1. Suppose y plus 1 is less than or equal to 0. Then y is less than or equal to negative 1. Combining with the domain y at least negative 3 gives the interval from negative 3 to negative 1. Step 4. Case 2. If y plus 1 is greater than 0, we can square both sides safely. That gives y plus 3 at least as large as the square of y plus 1. Move terms to one side to get a quadratic inequality. Step 5. Take the union of case 1 and case 2. Together they give negative 3 less than or equal to y less than or equal to 1. Step 6. Use the change of base formula. Log base x of 2 equals 1 over log base 2 of x. We will solve the system in two subcases, when x is between 0 and 1, and when x is greater than 1. Case A. If 0 is less than x and x is less than 1, then log base 2 of x is negative. Multiplying inequalities by a negative number reverses the inequality signs. From 1 over log 2x less than or equal to 1 we get log 2x less than or equal to 1, which is automatically true in this region. And from 1 over log 2x at least negative 3, we get log 2x less than or equal to negative 1/3. Exponentiating base 2 gives x less than or equal to 2 to the power negative 1/3. Case B. If x is greater than 1, then log base 2 of x is positive. Multiplying by a positive number keeps the inequality direction the same. We obtain log 2x at least 1 and log 2x at least negative 1/3. So together we must have log 2x at least 1, which gives x at least 2. Finally, take the union of the 2x intervals. From 0 to 1 over the cube root of 2, open at 0 and closed at 1 over the cube root of 2, together with all x at least 2. That is our complete solution set. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.